Okay, let's see, today is April 26th, 2019. This is the regularly scheduled Friday morning meeting of ITSE 2309 at College. And let's see, today we're going to today we should pretty much finish up the SQL that is an integral part of this class, and we did that, and it's kind of where I like to be with 2 classes remaining, wherein we can kind of bridge and to see what comes next. I don't intend to try to teach the next class. The next class is ITSE 2347 if you are it's what we call the WECM rubric. If you move to UNT or UT Dallas or something like that, it will be a different number. From here we go into more programming. So I'm going to finish up today, finish essentially the part of the book that was designed to be in this class. Next class, by the way, I keep the same book. I'm less tied to it. I've followed it pretty closely, but I'm less tied to it in the future. So today we're looking at module. What modules are we on? I'll get them here. Let's see, not this one. By the way, I did, I'm aware that I left for Easter, and the other class, not the online class, has still had their, the test was still locked, which is a little embarrassing. Okay, today I'm going to go back and review the using database views, and then I'm going to back up to module 13. And so then after we do, so database views was 14, 12, 13, and 14 can really come in any order. So I'm going to finish up 14 and then back up to 13 today. So using database views, I wanted to talk a little bit about another command that I don't talk a whole lot about, and that, pardon me, I guess I should turn my overhead on. Turning it on. Wait for the overhead to come. But that's the idea of altering a table. So we've seen insert, update, delete, select, but I can also execute a command called alter, and it's coming up now on the screen. Alter table vendors, for example. Add the field vendor active. It is a tiny int, and I'm giving it a default value of 1. Now, when I add a column and I give it a default value, it does not set everything to 1 that's in the table. It's just null. It would be if I don't give it a value, it's going to be 1 when I do an insert. So if I just insert into vendors without giving it any value, it gets a 1. Okay. Now I use this, and I'll typically do this in a table where I do not want to delete from the table. So I'm going to use this as kind of a true or false. TinyInt is 1 byte. 1 byte is as small as I can access. Back in the old days, SQL Server tried to cram 8 Boolean values into 1 byte. So it was one bit. 0 was false, 0 was false, 1 was true. True was true. And it just didn't work. They spent more time in there messing with that thing to trying to get it to work right, and it just never did. So they don't give us what we call Boolean. Boolean meaning true or false. Basically, you just make your own, and you just use a tiny int, and 0 is false, true is 1, or anything else is 1. Anything else is true besides 0. Is kind of the way that works. So vendor active, if it's 1, that means the vendor is active. If it's 0, that means that I haven't seen that vendor in 10 years. They're out of business, their phone's disconnected, but I don't want to delete the record. Okay. I have to go through, and if I want them to be 1, I have to go through and set them to 1. So if I were to execute this, all right, use AP. I don't know why it didn't. It is usually a good idea after you do anything that changes the table, that it is usually a good idea to do a go. You don't have to have a semicolon after go. Go is not it is not an SQL command. It is unique to SQL Server. And basically it separates the batches. Now you can change what they use over there in your settings. You can change it. You know, right now they're using Go. They say, okay, what else do you want to use? I suggest you not change it because that's really going to confuse everybody. But if you were to put that into Oracle, it would not work. Oracle, it's a different command. And then update. So 122 rows got updated. If I were to look at it, I would see it. Okay. If object ID active vendors is not null, drop view active vendors. And I'm creating the view active vendors as select everything from vendors where vendor active is 1. So that's going to get them all, I believe, when I say execute. And now I say select from active vendors. I get all of them. Notice that I also get that vendor active. Now, if I were doing it for use, I would probably hide that vendor active. I might hide vendor active from the user. I might just select everything except vendor active, right? Not show it to them since it's got to be 1. So maybe I'd show it to them. Maybe there'd be reason to show it to them or not. I don't know.
Is it just a glitch in SQL Server that vendor active is treated as though it's not a valid column?
Here?
Yes.
With the red line? Get over it. Yes, it's just a glitch. If that bothers you, you can right click it and say, what is it, IntelliSense enabled? Sometimes it's helpful. Sometimes it's just an annoyance. I don't pay a whole lot of attention to it. Sometimes if it just, it hasn't found it yet. I don't know what the problem is. Okay, update, and mine I have one that's 0. I'm going to set, notice that I'm updating the view. Well, can I do that? Yeah, I can do that. Moreover, I can insert into the view, even if the vendor active is not in the view, I can still insert a row into the view. And because I can't give you a value for it, it's going to take its default value, and it's going to be 1. So if I insert into the view, it's in the view. Cool. And that's the way I like this to work. Now, notice that I'm now going to, quote, quote, air quotes, delete this. I'm going to set vendor active to false, where the vendor ID is 1, and I believe that's US Postal Service or something like that. I don't ever worry about trashing my data because all I have to do is run the script. Okay, so if I execute this, get 1 row, and now if I look at it, number 1 is not showing that, as if it were deleted, but it's not deleted. Okay, but it's gone as far as I'm concerned from this view. Well, I did update the table, yes. It went through and updated the table. I updated the view, it updated the underlying table. Yeah. And that's what they will do. You can do that, okay, when everything that's in the view, if the view is not based on a join, you can update it. You might be able to update it even if it's based on a join. But I'm going to say, if it's not based on a join, then you can update it. It's not necessarily so that if it is based on a join, then you can't. Sometimes you can, sometimes you can't. Notice that this one updated just fine. Okay, this is a different one, active vendors 2. Didn't really need that. Create view, active vendors 2 as the same thing. And with this one, I'm adding one more line there with check option. With the check option. I'm going to execute this one. And I say update active vendors 2, set vendor active 0, where let's delete vendor ID number 2. This one will fail. And the reason it failed is because I added this one, this with check option. Now what with check option does, it gives you an added layer of security in the view. Sometimes the views are used for security purposes. I believe I told you last time about HR, didn't I talk about human resources can see everybody's records except human resources. Somebody else has to manage them, okay? It says that you can update the view, you can still update the view, but you cannot update the view in such a way, using the view, you cannot update the view in such a way that the record no longer appears in the view. That makes sense. Because you would have modified the set of records that you're looking at. So if I could do that, I could change a record and then send it to another view. And that I'm not allowed to do. So these guys are, this is what gives us security in the view, the with check option. Okay. Some database products are, by default, they block you. Most of them have now gone to with check option. If you want it to, in some products, at least fairly recently, you had to say when you created the view, you had to say not add the security, but to take the security off. I think we've kind of gone to this one where the with check option, I know it works this way in Oracle now and everything. If you add with check option, that says stop any changes to the data that would change the records that are showing in the view. I can change everything else. I can update the vendor name. I can update the vendor phone number. I can delete a record. I can add a record. I don't think it will let me, if it's got the with check option, it will not let me add a record to vendors and put a 0 in vendor active. But it'll let me not put anything, and then it'll default to the 1. Okay. I don't think it will let me put a 0 in there. So I can insert, I can update, I can delete from a view. So a view is just an SQL statement that you have put a name on. It's just an SQL statement that is stored in the database in somewhat of a compiled version. It runs fairly quickly. It does not add much overhead. They can be created and deleted as you please, kind of on the fly. It's not a particularly big deal to create a view, use it, throw it away. Okay, questions about that with check option? Top 10 demo 1 is my view. If it exists, drop it. Notice whenever you create a view, creating the view has to be inside of its own Go block. Can't have anything else in there. So I'm creating the view top 10 demo as select top 10 invoice total from invoices. It'll let you, okay. And now let's take a look at it. Okay. Top 10 demo 1. Okay, and I got these guys. Now, the problem is that that's not the top 10. Why isn't it the top 10? Because I didn't have an order by. Okay. So if I were to select this, I'm going to see that these invoice totals are really a lot bigger. There's the top 10 right there. And that's not the same thing as I got a minute ago, not even close. Okay. So I'm going to create a view. I'm going to call this one top 10 demo 2 as, now some platforms, Oracle, for example, will not allow you to do this. Oracle won't let you do this. But in SQL Server, you can. And so I can create the view. And now I will copy this. And I have to make sure I select from top 10 demo 2. And this should give me the same thing, okay? Now, notice that this has an order by on it. I cannot guarantee that the output of the view, that this select statement, I cannot guarantee that that is going to be ordered. It probably will, might be, but I cannot guarantee to you that that output is going to be ordered because a view is a table and a table is not ordered. Okay. Now, Oracle will not let you do this. Oracle will not let you create that view, and others won't either. Sometimes you have to do something different. What about this? Select top 10 invoice total from, select invoice total from invoices order by invoice total descending. Now notice that at this case I'm using a derived table. So I'm hiding the ordering in the derived table. Okay. Now this is how you would have to create your query in Oracle. Oracle will let you do this. But if I try to do this in SQL Server, I get a big red mark there, and it says, you can't do that. Now, my question is, what is so different about this. Am I not in this derived field right there where I'm selecting from this? Isn't this really a view? What is so different about that and this? They are essentially logically the same thing. And I don't understand why some platforms allow one, disallow the other, and vice versa. Okay.
Just to clarify, top demo one only did this to the first 10 entries. Is that what we saw?
Right. That's what top does. It takes the first 10 entries from the select statement. So if you want to get the greatest performers, you have to order by descending. And that's fine. When you create a view, though, now, let's see, create view. When I create a view out of that, I am implicitly ordering that view, or might be. And views are not ordered. Now, I've never seen a time when it came out when you said select from top 10 demo 2 that it did not come out ordered. It may happen. It doesn't have to be ordered. It's just you're going to get the top. You're going to get the top a set of 10, and in that will be the top 10 performers in terms of invoice total. Okay. I don't know why this won't work. Okay, what's the point in a view? Why would I want a view? Other users, this is probably the first topic that's really stepping into programming now. Because as I create these views, I'm creating views typically for other people, right? I'm the programmer, and I'm probably creating the view for the world, my public, my users, okay? It might be a web page using it. It might be other SQL. Other people might be taking this and using it at work or something. So I create the views, active vendors, for example. I don't want you to have to go in there and see 23,000 vendors when I only have 110 that are active. So I don't want you to have to sort through all those. So I'm going to give you this view. I don't want to delete my inactive vendors. I want to keep them there because I'm still using those data, but I only want you to see the active ones. That's where you're concerned. So what I'm going to say is I'm going to grant select. I'm going to let you select from my view. And to you, it will look like a table. Now, you'll have to qualify the view. When you say select from the view, you're going to have to say select everything from, you're going to have to say it like this, select everything from SW Smith dot. It's not quite that simple. There's I need to make you a user of the database also. But given that you can see my database and you are logged into the server, now you can select from my view. I could have let you select from the table. I could have said grant select on vendors. I could have, but I chose to give you the view. You don't have any rights on anything unless I give them to you. Okay. So the rights that I can give you on these views, I can give you select, I can give you update, delete, and insert also. If I give you update, that lets you update the view, depending on how much I trust you. If all I give you is select, that means you can see the data, but you can't do anything to it. If I give you update or insert, now you can add rows or delete rows. If I give you, well, you can change rows or delete rows or insert rows if you have these other. So I have to give you explicit, we call them privileges in database, not really rights. The owner of the database has all privileges. You can update, delete anything, and there's no way to stop the owner from it. You can also grant alter, but I suggest you never do it. Why not?
You can mess with database.
Yeah, such that it stays messed up. If I have alter, I can alter the view such that it shows something different. So I just, that's one I never give. Never, ever, ever. Sometimes, typically speaking, when you're in database, you have these different hats that you put on. So on one hat, that is, you are the system administrator. That is where you log in typically with Windows authentication. And in order to do that, you have to be sitting at the terminal, at the machine. Well, I can lock that up. Put that in a room, lock it. Nobody can come in and log in remotely with Windows authentication. Well, they can if they have remote access, but I mean, we just don't give that. Okay, so you have to be sitting there. So that's your system administrator. System administrator, I can drop databases, create new databases, create users, drop users. Now, when I create a database, I might make you, you're the programmer, I might make you the owner of that database. Or I might keep the ownership myself and give you alter on it. And that lets you change tables and stuff like that, create tables. Most probably I would give the programmer, I would make the programmer the owner of the database. I trust the programmer. Why do I trust the programmer? It's probably me. So if I want to drop the database, I have to go back over to the system admin. If I want to create another user to test something, I have to go back and log in as the system admin with Windows. But if I'm just programming, I am the I'm the programmer. I'm the DBO, the database owner. Now, maybe I want to create a user, and I'm going to call this user John Doe. And if I want to create this user that has no privileges, I have to go ask the admin, hey, system admin, create me a user. They do, of course, because it's me. So I've got 3 different users now. And so I would grant select or grant whatever I wanted on whatever object to J Doe. Then I could go log in as John Doe and test what he or she can do. Okay. Before I put it out to the public. So then when I say grant to others, I know I've tested everything in there and I've made sure that John Doe can't get to anything that he's not supposed to get to. Okay. So it's this grant idea that lets me do this. So I can grant what? I can grant update, delete, insert, or select. We're not going to talk about alter. We don't want to ever do that, but you can do that also. We don't. On any object that we know about at this time. What do we know about? We know about tables and views, essentially. Okay. Questions? Now, what I'm going to do in the next couple of days, I'm going to kind of bridge into the next ideas. And SQL proper that we have been doing all semester is pretty simple. You might not think so, but it is. From here, everything gets a lot more complicated because SQL is ideally the universal language of database. In theory, SQL that we have studied in SQL Server just drops directly into Oracle. Now, it's not going to happen if you try it, but the theory is that on each individual select statement, it probably should go in there, okay. There'll be a lot of little differences. For example, Oracle will not let you have a completely blank line inside of a statement. Oracle will insist on semicolons. There are some slight spelling differences. When you get into dates and times, they're slightly different. When you get into casting a date, they become slightly different, but you do the same things. So moving from here to Oracle should be pretty much a piece of cake. Now, as we move to the programming side of things, the languages look quite a bit different. They're not even close in terms of syntax. They still do the same things. If I were likening it to a car, I guess you would sit down at the controls of a new car and you'd find your gear shift lever someplace on the different side of the car, and it wouldn't say D and N and R and P for park. It would say CQDX. Okay, and they wouldn't be in the right order. And how long would it take you to do that? I wouldn't just sit down and do it, but it wouldn't take me very long to figure it out. If I put it in some gear and it went backwards, I'd, oh, that's reverse. Okay. I test it very gently at first. So while it's different, everything is there and it all works essentially the same way. So it's just kind of a matter of getting it into your head. It's kind of like driving on the left. You drive on the left the same way that you drive on the right, except you're on the left and everything switches over, or should. That's the theory. Okay, what we will find, what I think I'm going to do is I'm going to talk a little bit about writing code that is compiled. Up until now, everything that we've been doing, all of this stuff that is here in this window, this is just a little batch window. It's executed one line at a time. It doesn't save it any place. It's just there. In SQL Server, I don't have the ability to execute a file. That's one thing I really wish we had. And you will too, if you do much programming. So I wish I could say, okay, execute this file. So I have a file of SQL commands. And what I would like to do, I would say, okay, SQL Server, this file named mycode.sql, I want you to execute everything that's in that file. Oracle will do that, SQL Server will not. That is a big, I don't know why. I'm assuming there's a reason they haven't added that. What I can do in either one of them, I can write a program. This program is compiled. The compiled executable program, if you're with me, the executable program is stored in the database. And now I can execute that program. That means I can take SQL programming language, write a program out of it, compile it, and then execute it at very high speed. Okay. Now I can save that as executable. Nobody can read it. Nobody knows what it does. And I can grant. So what do we do? I have grant, where's my grants? Down here. I have grant, update, insert, alter. I also have, I can grant execute on a program that I have created. I own the program. I can allow you to execute the program. If you execute the program can do anything I write it to do. The program can insert stuff into tables, various tables, and you don't know what it's doing. You can't see the tables, but nonetheless, by executing this program, you can change those tables in such a way that I tell you you can change the tables by my code. Okay. And that's kind of the first step of the next class. We're writing that code. It exists in all database languages. All of them have something like that. The languages themselves, the syntax of this wrapper language, I'm going to call it, is different. It depends on which database you're in. And it'll look completely different from one to the next, but it does the same thing. The things that it can do are pretty much standard. Okay. And that's the next class. Okay, are there questions on views, creating the views? In general, let's go back to a view. What is a view? What? Okay, it's a table if you like. It is a SQL statement. It is an SQL select statement. I cannot make a view unlike when you're in Access. Excuse me, Access. Some of you have taken Access. When you create a query in Access, you save it. Is that really a query? That's a view. That's a view. Okay, I can create a query in Access and save it. And this query can create tables. It can update tables and stuff like that. Well, that's not really a view. It's not really a query. Okay, so real database platforms won't do that. A view is only a select statement. You cannot create a view on an update statement. Won't work. You cannot create a view on a create table statement that creates tables. So a view just simply returns information to you. It's just a select statement, period. Okay, so it looks like a table that you can select from. Now you can insert into the table. You can delete from that table under some conditions. Insert under some conditions. Update under some conditions. So the view can be used that way. The simpler it is, the more likely you are to be able to insert, update, and delete.
What is the difference between the view and the table?
Well, the view is a saved SQL statement. So it acts like a table, but just because it's kind of a picture of a table, I can't always, because I could have a join in there. I can have cumulative or aggregate functions in there. So I can say select max invoice total from invoices. Well, you can't update that. How are you going to update the max? Select sum of, instead of getting something I update, I get a quantity, I get an aggregate, I get them all added up, and it gives it to me in the view. Well, how am I going to update that? Obviously, it cannot be updated.
Dr. Smith, is there any performance rule that would say create a view as opposed to a new table to like speed it up when you're doing a select from?
Create a view as opposed to a new table, yes. No, not really. A view is going to be about the same as the select on the underlying table. Most of the time that would be something like, okay, here's a view. Create the view, top 10 as, and I say some platforms won't let you do this because that puts the order by on it. Okay, how is that different from this? I think is really a better question. why would I use a derived table such as this as opposed to creating a view, create a view, then select from the view, and then throw the view away? It would probably be a little bit faster just to go ahead and use the derived table. But creating a view is generally not considered a drastic thing to do. Creating a view, using the view to access the table doesn't seem to hurt the performance any. I would assume that having it, materializing it in a table would give you a little bit faster access though. It would depend on how complicated the SQL statement was underneath it. I can create a table from an SQL select statement. I can create it and send it over to another table. But I really don't want to do that if all I'm going to do is turn around and drop the table. Is that your question? I'm sorry, who asked that? I didn't see them.
Yes, sir. Yeah, that was exactly it, because I've heard people talk about
Okay, Brad.
when do you materialize a table versus use a view, and I didn't know if there was kind of a rule of thumb as to size or performance or things like that.
Yeah, there are some rules on that. Now, what Brad's talking about here is I can create a table from an SQL select statement. So I could create table vendors one as select everything from vendors. I think I've got that right. And what it would do, it would make a copy of the table. I could create a table that's part of it. I could create a table using aggregate functions. So I can create a table from a select statement. So I materialize the table, and now it's saving all of that stuff. And now I select from that, as opposed to creating a view. And the question is, which is faster? And my answer to that, I guess, is it depends. How long will you use that table that you have created? Do you expect it to, if I update the original table, do you expect your new table to update? That'd be one question, Brad.
Yeah, that's a good point.
Your table isn't going to update. Go ahead.
Yeah, it doesn't automatically update after you create it. Right.
But if you create it as a view, any changes to the underlying table reflected in the view. So I would tend to say that you'd want to avoid, I would avoid materializing a new table unless I really wanted it for something. I need a snapshot of it now to save and keep forever. In that case, I'd probably materialize it.
Is there any difference in space used or storage when you have a true table versus a view?
Oh, a lot. A view is a view doesn't create any new data. That's its beauty.
Okay, all right, that's the trade-off. That's good.
Right. The view is just simply an SQL statement that is saved, but the data are not saved. So if I change the underlying table, the view, everybody that looks at the view sees it changed. Most of the time.
So it's really like passing by reference.
Question is, it's like passing by reference. Is it like passing by reference? I guess you can think of it that way.
Since
you can alter it. Passing by reference has more meaning than that. When you're passing a memory address,
I was just trying to.
You can alter it. We don't use, in database, we don't have that term pass by reference come up very often, because even when we're programming in procedures, database just does it differently. Database tends to make copies. That's just the way databases are. But with a view, You don't make a copy of anything. All you do is save the SQL, and then every time you say select from that view, you run the SQL. Now, is that any faster than just running, or is that any faster or slower than just simply running the SQL against the table to start with? I don't think there's much difference. Okay. Whether you create a view or use a derived table would be the best thing, would be the best answer. So, for example, Juana in the derived tables was creating a view. I mean, that's okay. I didn't knock it. Instead of, and then selecting from that, whereas, okay, back to, let me put what I'm talking about here. Okay, this one, a derived table. This is a derived table, and it's got a name D. Okay, and I'm pointing out this doesn't work in SQL Server. Okay. These two lines taken together accomplish the same thing. Create the view and then select from the view. This one tries to select directly from the SQL in the from line. So this is the derived table approach. And this is the create view approach. They both would give you the same output, but sometimes they'll stop you from doing one of them and let you do the other. Create the view, right? In SQL Server, it will let you create the view. In Oracle, it will not. In Oracle, it will let you do this. In SQL Server, it will not. Well, other questions?
So if you use a few views for your customer or your client or whatever you call it,
Okay.
you need to be getting a really, really good process of backup.
The question is, if I use views for my what now? For my vendor clients.
Are the ones that are administrated the database.
Okay.
You need to have a really good system that is backup.
Well, yeah, backing up that might be a good topic to finish up with too. Is looking at backups and backup. How do we do a backup? You back up the database pretty much the same way you back up anything else. The same words apply, you know, full backup, incremental backup, differential backup, all of that stuff applies. And you can, you know, have a tape that backs it up every night. It doesn't really apply to the view though, because the view is no more of a risk than giving them access to the table. I don't want to give you direct access to my table. I want to filter what you are allowed to see. Not because I don't trust you, but because I don't want to overwhelm you with a lot of data that you don't need. Therefore, my idea in creating this, this view, active vendors view up here, was so that you didn't see all the inactive vendors. Now, the downside of this one with the check option is that you cannot, quote, quote, delete by setting it to 1. So this is how you would delete somebody from the view. Now, I can stop you from deleting from the view. I give you grant select on my view to Juana. I grant update on the view to Juana. I grant insert on the view, but I don't give you delete. So you can't delete from that view because I didn't give you that right. But I gave you update. So if I gave you update and your view looked like this one, right? Active vendors, and I give you update, I give you insert, I give you select, update, insert, select, but I don't give you delete, I don't give you alter. Don't trust you that much. Now you can delete because you can update that view. Therefore, you can go into that view and you can set the active fields to 0, and they disappear as far as you're concerned. They haven't been deleted.
Yeah, but for example, I'm sorry, I don't get that. I'm talking about backup. Is because in the view, when you give a authority, some people to even update, the field, the record, or the row has been changed.
Okay.
But they changed their mind, or they screwed up.
Yeah.
So you need to have the backup because that's data.
I hear you. Juana is asking about backups, and I say, have you hugged your backup today? You know, do you need to back up? Yes. Do your users screw up? Yes, they do. Do you? I don't ever. Delete from vendors, and you accidentally press enter or execute. You fat finger it and hit execute. My wife was pointing at something on her touch screen, and she pointed, and she'd been working on this email for an hour, and she says, well, what about that? What did I touch right here? And she touched the delete, and boom, goodbye. And she was just in tears. Yeah, and SQL is very, very unforgiving. So you don't want to give your user access to SQL. You don't want the users writing SQL unless you really, really trust them and they are really programmers. Your users, your people out there that are just manipulating the data, secretaries and those, are going to be using programs that you write. And I wanted to go into them a little bit more, but not today. Okay. Take a short break. I'm going to pause the recording. And let's see, it's 10 minutes to 11. I'm going to start, and then I'm going to do the last topic, which will be indexing. A very easy and very, very deep. Still water runs deep. Okay, I'm going to pause the recording. Okay, check mic. Okay, I'm told I'm working. I'm going to pause the recording here in just a moment because I'm going to play this. I'm going to play the Two Ronnies. It's kind of a humorous skit. And so instead of playing it for the recording, since it's here recorded, I'm just going to let you, if you're viewing this at a later time, I'm going to let you go ahead and view it. So I'm going to pause the recording, and then I'm going to play the Two Ronnies, the confusing library. So pausing the resuming recording. Now, if you're watching the recording, yeah, checking the mic. Okay, if you're watching the recording, you won't see that because I didn't waste bandwidth to put that in the recording. But just go and take a look at that, and that demonstrates the idea of indexing. And a library is a very good example of an index. Next. There's a good tutorial there. I'm going to pass that. Database indexing. I have some pictures. Let me see if I can get to my. Okay, there's the pictures of a library card index. And you have to be somewhat older than most of you ever to have seen one of these, except maybe in a secondhand store or something. Back in the old movies, back in the old days, oh yeah, if you watch, what's the Ghostbusters? Who you gonna call? They showed this where the cards are getting all scattered. And anyway, they had these cards in there, and they had 3 indexes. They had an index on title. So you could go to this index file and I could look up the title of a book. I want to read, I don't know, Moby Dick, and it would take me directly to where it was stored on in the shelves. So I didn't have to search for it. I didn't have to go out to the shelves and just go down through the shelves searching for it. Or I could go to a different index, a different color-coded index. What color? Titles were red, I believe. Authors, I think, were blue, as I remember. I'm not real color-oriented. And so I could look for the authors, and I could say, I want to read a book by Herman Melville. Herman Melville wrote Moby Dick. He also wrote Billy Budd stories, 2 years before the Mast, and a lot of other books. And if I didn't want to look at that way, I could search for books about whales, and I would find Moby Dick, and I would find a textbook of cetology, which I believe is the study of whales. But anyway, those are the three major indexes. Now, I would not, well, let me point out some things. They took up a significant piece of real estate in the library's lobby. At a large university would have almost probably a space twice the size of this room dedicated to nothing but these card indexes. So you could spend a good bit of time in just the index. But it would certainly be a lot faster than going up and just going up and down the aisles looking for it. Okay. Okay, they still today, even today, well, we don't have these anymore. We don't have these card indexes, but we have computers that do it. Nonetheless, the indexes have not taken up any less space. They just take up digital space now. And so they do take up a lot of space in our database, similarly to what they have been taking up. And we'll talk about that today. Let's talk about what I cannot search for in an index. I want to find a book that has 371 pages.
Can't do that.
Why not?
It's not written on the card.
Why isn't it written on a card?
And it's not organized.
Why isn't it organized? I want to find a book. Yes, I want a book that's 371 pages. Only a nitwit is going to search for that. And we don't have to cater to nitwits.
And also, back with those card stocks, you only got 3 organizations.
Yeah. Well, I could put another organization in there.
But then you got to have room for them.
I got to allow room for that. So if I were allocating, if that became important, and I really needed to find all the books in the library that had 371 pages and find them quickly, then I would build an index on that. And I would have to go out and buy another card catalog, and I would have to employ somebody to keep track of them. Okay, so it would have a cost. It would have a big cost, but I could do it. That's my point, is that indexes cost. You don't index everything. Very judicious with your use of indexes. So we have the 3 in the library. They're a complex data structure separate from the actual data. However, they must maintain a copy of some of the data. So the index has to copy some things. For example, this is the, I don't read German. Do I? You read German? Okay. Oh, there it is. Title index is red, author is yellow, and the subject is blue. Okay. I want to find a book that contains 376 pages. There aren't any indexes for a book that contains 376 pages. I'm going to have to start at the beginning of the shelves and go through with my little cart and check each book and pull it off and put it on the cart. It's going to be quite time intensive. I can do it. I can do it. Yeah, sure. Why not build an index? Consider what the librarian has to do. He or she has to type out all those index cards, and it's very expensive, and nobody except a utter nitwit, ever searches for a book that has 376 pages. Why would you do that? Example 2, we can judge a book by its cover. Do you really want to read a red book or a blue book? Back to that skit. How many different colors do we have? I'm going to say 5. I'm sure there are more. The problem with it is that it's quite likely that on any given shelf, I'm going to find one of each color, probably more than one of each color. So how am I saving anything by using the index if I'm looking for a blue book? If there were such a index, right? I'm going to have to touch every shelf on every bookcase. I may as well just start going through there with my very big cart and just pulling them off. I'm going to get done faster than I will using the index. And it's still not going to be very fast. So that's an example of an index. I want an index that is more or less unique. So for example, an author's name, if I search by an author's name, I can get duplicates. Particularly if the name's Smith or something like that. If I'm searching last name Smith and that's all I know, I'm going to find quite a few books. I need to narrow it down a little more. I really don't want something that's going to give me 20% of the whole database. Right? Using an index, if I'm going to have to, if it's 20 to 25% of the entire collection, I'm going to say if it's even 10% of the entire collection, it's a poor index. Example 3, sometimes books come with abstracts. They're about 1 page or so, tells you something about the book. You'll find that a lot in academic studies. They'll tell you a little bit about it, just kind of a blurb. Should I index that? Well, what's on the index card? That means I have to reproduce that abstract on the index card. And it's going to be quite consumptive in terms of space. It's going to take up a lot of room on the card. So I want something that's small. I like a name, a person's name. I like a number, like a library call number, a social security number, or something like that. Okay. Hello, Paloma.
I'm here.
Okay. Yeah. Got. Okay. There we go. We're fine. Something's being checked in or out. Should we index the field that indicates whether it's checked in or out? Tell me about what happens to check it in or check it out, or things change a lot there. Something that is changing, something that is highly fluid does not make a good index. So I've got 4 basic rules here that tell you when to index. Number 1, do not index something silly like number of pages. If nobody ever searches, nobody cares, don't do it. I would say the color is probably also silly, but the thing about the colors is there's only 5 different colors of books in my world anyway. Something like a zip code. If I'm indexing all the houses in Plano and I go by zip code, how many zip codes are in Plano do you think there are? What? It wouldn't surprise me if there were 20. It's pretty good size.
The only library that I could see anybody searching for a number of pages is if it's in a school library.
Okay. Well, we won't search for a number of pages. That's my example of something that we shouldn't fool with.
Yeah.
Okay. ISBN is a great one because that's a primary key.
Yeah,
Yeah, if it's a primary key, you want that as an index.
It's 13 digits and what, maybe 5 fields?
Right. Well, whatever an ISBN is, that is your primary key for a book. And anytime you identify a primary key, that's an index. Take it to the bank. Okay. the one about the color or zip code or something, if I've only got 20 zip codes in Plano, yeah, it's a poor index, because if I search for the zip code 76209 or whatever it is in Plano, I'm going to get 5 or 10% of the whole city, and that's not a good index. It's just easier just to scan the table, go through the whole table, because I can do that pretty darn fast. I can do that at about, million records a minute or so. So if it's got very few values, we call that a low cardinality. High cardinality means I have a whole bunch of different values. Low cardinality would be a telephone number. Two people might have the same telephone number, but that isn't going to happen very often. Husband and wife would have the same telephone number, maybe. I don't want a big field. I don't want a varchar 50. That's too big. I want it small. I want to keep it nice and small. That's the, remember the social security number I pointed out, we're going to run out of digits on 9. And I'd say I'd start pushing it up. I don't want to push it up because that's a primary key. And as it gets bigger, it's going to cost me more than pushing the size of your name up. Okay. And then I don't want something that's fluid, that changes a lot as an index. Now try going down to the Social Security Department and saying, I'm really tired of my Social Security number. Can I have another one, please? No, don't even bother. They're not going to give you another one. Driver's license number is going to stay the same. Your first driver's license you got in Texas stays forever, as long as you have a driver's license in Texas. Well, that's true.
Or
Stolen or something like that. Yeah. So there's our 4 guidelines. Next. Okay, here's a table, just a demonstration table. Create table, demo table. Integer, integer, integer. Here's a constraint. Primary key. Demo 1 is the primary key. Here is a constraint. We haven't talked a lot about unique, but I can create a unique constraint. We don't do it very often. They tend to be expensive, but I can create a unique constraint. What's going to happen whenever I insert something into that table? It's got to check the whole table. Therefore, it's going to create an index automatically on demo 1 and demo 2. They automatically get indexes created. 1, because it's a primary key. 2, because it's unique. Has to be there. In Access, it asks you, as you're going through and you're creating a table, it says indexed, yes, no. If you say, no, it says indexed, yes, duplicates allowed, yes, no duplicates, and no. Okay, so that's the idea of I can create an index that is not unique, or I can create the index unique. Creating a constraint like this with unique essentially creates an index, no duplicates. If I wanted to, if I did not have the word primary key, I can create a primary key by making it required and unique. It's a primary key, or it would work for one. To insert either one, they have to already search. They're already indexed, don't create an index. Well, when we get to actually, once you've decided what to index and why to index, it's about as simple as it can get. There it is, right at the bottom. Create index. You have to give it a name. The name of the index must be unique in the database. Therefore, I recommend that it have the name of the table in it and the name of the field that's indexed. And then I always append index to it. Some people will abbreviate that and say IDX. Some of them will put that at the beginning, IDX demo 3 or something like that. It's develop some kind of a scheme where you can look at a name and tell what it is, where it comes from. But in the database, an index has to be unique. You cannot have two indexes, even on different tables, named the same. Okay, pretty easy. If you've chosen your field correctly, you can speed it up by orders of magnitude, 10 times faster, 100 times faster, 1,000 times faster. Okay, if you did not choose it correctly, and if you are just, oh, let's have an index. I don't make an index. That makes my searches faster. Not necessarily so. It can slow it down. It can really trash your database if you're not selecting them carefully. So they have to be chosen carefully. Pretty easy. It's just simple. I mean, create index, give it a name, on, give it a field. Now you can index more than one field. For example, if I have an index, if I have a first name, last name, I can index first name, comma, last name. Right. Now, if all I'm providing is a last name, it's not going to be able to use that index. So if I wanted to have an index on the last name and an index on the first name and last name as a pair, I would need two separate indexes. Okay. Usually, I can't tell you what usually to do. Okay, so do not index primary keys. Do not index unique. When should we index? I'm talking about do not. Frequently searched fields. Okay, foreign keys are usually, not always, but usually good candidates. Almost unique. Can you say almost unique? It's either unique or it's not. It's like saying I'm almost innocent. You either are or you aren't. But if it's almost, well, a foreign key, it depends. Yeah, I can think of one. Terms ID would be a poor candidate because terms ID only has 6 values. So it's not a good, it would not make a good candidate just because it fails that almost uniqueness. In general, a foreign key, because it's usually searched frequently, is usually a good candidate unless there's something that says, no, that's not a good one. Now, a foreign key is something like, you know, gender. Well, there's like 2 that I know of. I gotta be careful. Gotta be careful. Be careful. Okay, I like a small scalar value. Scalar means that I can sort of, 1 is greater than 2 is greater than 3. A is greater than B is greater than C. Those are scalar values. Well, these are guidelines. You would have to decide, are you going to be searching for first name and last name together enough to justify it? It will have a cost. Everything has a cost, and the indexes do definitely have a cost. Static data that don't change. Let's see, when you sign up for a class, I sign up for a class, I go to it and sign up and I put in you signed up for this class. Now you're in this class. What happens if you drop the class the first day? Oh, I don't know about your money, but you were never in the class. I don't know about your money. Your money's probably gone. They give you what they haven't spent yet. Okay, but you weren't in the class. And so that's true. And if you drop the 10th class day, you were never in the class. On the 12th class day, you're in the class forever, right? You get a grade, some kind of grade, W or whatever. Now, why is this so? It's because at the beginning of class, what's everybody doing? They're switching.
Perto que você vai apanhar.
Okay, mute your mic. It's everybody's switching, and they drop the indexes because they're going to be working with the data a lot. On the 12th class day, they recreate the indexes. So it's a lot faster to drop an index. Now I can recreate the index. The one that's very difficult to drop is a primary key. You have to leave that one in place, and unique. So you cannot disable a unique index. You can disable indexes, and then go back and re-enable them, and they'll rebuild themselves. So they are really quite complicated. So I've given you the rules. Let's see if we can look at one quickly here. Don't you want to write one of this code? Right. This is a pretty decent. I'm not going to play this guy. You can play it and look at it. An index is I say it here, a monstrous complicated data structure optimized for searching. If you go on for a 4-year degree in computer science, in your junior year, your 3rd year, just before you become a senior, you will probably get to write a B tree, also known as a B+ tree, B* tree, goes with several names, there's slightly differences. Each one of these nodes in the tree is really a disk page. So for example, if my key is 19, if I'm searching for anything below 19, I follow this address down to this disk page. If it's above 19, but less than whatever this one is, I follow this pointer. So since, let's see, I'm looking for 19. Let's see, is 19 below 24 or above 24? It's below 24, so I follow it down this way, and behold, I find 19. Okay, I found that in 2 disk accesses. Disk accesses cost about 5 milliseconds or so today. And there is probably where database comes into its own. If you look at processor speed today, what was processor speed? Oh, I don't know. Let's see. In 1980, megahertz. Slow. Well, yeah, lots of things have changed, but our processors are millions faster than they were in 1980. Now we're talking kilohertz, thousands of instructions per second. Today we're talking billions of instructions per second. Orders of magnitude, huge differences. What was a good fast disk access in 1980? I'll tell you what it was. If you got 20 millisecond disk access, that was pretty fast. Today, what is a good fast disk access? Well, no, not disk access.
Oh,
Disk access, it's in the 5 millisecond range. So the disk access has speeded up by 4 times. The processor has speeded up by millions of times faster. So what's our bottleneck is that disk. Yeah, there's nothing we can do much to speed up the disk. I mean, it's got to keep spinning. I know there's things, there's ways we can do it that are hideously expensive. Anyway, I'm going to talk about it here. Oh, it is. It's a binary search algorithm, but instead of being binary, it is 1, 2, 3, 4, 5, 6, 7. So in binary search, a binary search says I'm going to split it each time. So I'm going to search the dictionary, and I'm looking for a word. I don't know, what am I looking for? I'm looking for the word words, W-O-R-D. And I split the dictionary in half, and I go in the middle, and I find, what do I find? I find marijuana. And am I high or am I low? Okay. So I guess I'm high. No, I'm low. I'm below word. So I go to the high side of the, and then I split it there and split it there, split it there. Okay, this one's a little bit different. This one, it might appear anyway. I mean, so I look at 19. Am I above that? If I am, follow this one. I'll follow that one. Then I look at, then if it's not here, I look at that one. Then I look at that one. Then I look at that one. Okay, and I can scan these guys in memory. We don't worry about memory. If this guy's in memory, the cost is reading this disk page. I guess I should point here. The cost, I look at this one, and then this one, and then this one, and I scan across here. This is in memory. So this is a 4096 byte disk page. Always work in disk pages. Okay, let's talk about how big something is. How big is one row in the invoices table? Well, there's your sizes. The big one, I would change this one, invoice number. I wouldn't have it be 50 bytes. That's too big. And if that, I don't know. You know, how bad is it if it gets cut off? 96 bytes total is what I get. Wait a minute. 1, 2, 3, 4. 1, 2, 3.
46 is don't have number.
46 and then 50. Okay, 96 bytes. 96 is a multiple of 8. Something's wrong there. Anyway, I need to put a calculation to that. Did I forget the 50? 98. Okay, 98's a good one. What I would probably do is would probably go up by 96. I would probably go up to 106. I like staying in multiples of 8. 104. Give me a multiple of 8. Okay. How many invoices do I have? Estimate? I don't know. I mean, I know how many I've got now, but how many will I have in the future? Let's say 100,000 just for fun. Okay. Therefore, I have 100,000 times, well, we'll use 96. And I get that. I take a log base 2. And so if you have never worked with logs, that's one to do in your algebra. Pay attention to logarithms, pay attention to exponents. 2 to the 4th power times 2 to the 3rd power is 2 to the 7th power. Okay. So something like 2 to the 24th power bytes. Well, that's something like 16 million. Or 16 megabytes. And that's going to cost me about 1,024 disk pages. And it's just a small file. Right. I'm trying to ask, how big will my tables get? So if I have 100,000, this is vendors. If I have 100,000 vendors, so I have to go down the road and I have to say, if I have 100,000 vendors, how big will these tables be? And will I have enough disk space? If I have 100,000 vendors, I'm going to have about a 16 megabyte table. That's not bad. That's, you know, average size. Nothing unusual about it. It's when you get into the 10 millions that they get big. Average size, if there is such a thing. Let's index vendor ID. Why? I would, because vendor ID is a foreign key. Now that guy's going to get indexed. I mean, that's pretty much a no-brainer. How many integers can I get on? So what is he? A vendor ID is an int, 4 bytes. And that's real typical. An integer is typically 4 bytes. How many integers can I get on one page? Well, I have the value, 4 bytes, and I have a disk address. Disk addresses are usually also 4 bytes. So each entry costs me 8 bytes. So I can get about 512 of these integers onto one disk page, or so. And again, this is kind of a rule of thumb, about. If I'm off by 1, oh well, I'm not worried about it. At layer 2 of the index, so this is where I'm now going down to that second layer, second row of these pages. I'm going to have 512 pages, and this will hold up to about 250,000 integers. 512 times 512, roughly 250,000. It won't be that because it'll be an even number, but I mean, it'll be a power of 2, so integers. But we only have 100,000 to index. Therefore, I can do it just fine in 2 layers. My search tree is only going to be 2 layers deep. My search tree is going to be very fast. It's going to be 2 disk hits. So I've got 10,000 records to search, but I can find it in 2 disk accesses. I can find the one I'm looking for. Compare that to, that's using vendor ID, the integer. Now let's use invoice number. I'm going to use varchar 64 just because it's easier to work with. Now, how many of those can I fit on a page? I can only get 64 values on a page. So now each one, the tree is going to grow more slowly. The tree won't be as wide, but it will be deeper. Okay? Since the tree is deeper, I'm going to have more disk hits as I go down through it. So the cost of this index will be, well, the root, 64 pages, the next layer. So this is a level 0, 1, 2. This is a 3-level page. And the total cost of a tree that is full would be 24 megabytes. Well, good grief, it's bigger than the table. Yes, that can happen. Build an index, and the index is bigger than the table. Actually, it's going to be less than that, because the 3rd level will only be about half full, and the 3rd level is where most of the meat is. But it's still going to cost me an extra disk access every time I go through it. So that is not a good index. Well, I would not build that index for the simple reason that that value, that varchar 64 value, is too big to index effectively. I like something small. Okay, ISBN, social security number, driver's license number, something tiny like that. Okay, and then we look at what we get for that. If there's no index on the table, assuming a 5 millisecond read, it'll take me about 5 seconds to go through that entire 100,000 table. 5 seconds is a long time in computer seconds. I mean, anything takes you 5 seconds. If your stuff is coming in at one a second, and it's taking you 5 seconds to deal with them, you're in trouble. So using the index, if I just have to scan the table, it costs me 5 seconds. But if I use the index, first level is in memory, probably level 2. Thus, I read levels 2 and 3, and I get access to my data in about 0.01 seconds. 500 times faster. 1/100th of a second versus 5 seconds. Okay. It'll really speed you up. It can really slow you down. If nobody's searching on that, nobody is searching on the invoice number, right? I mean, I can search on the index number. It'll cost me 5 seconds if I don't have an index. So I can get it, yeah. I just have to plow through it. Don't like it, but I can. But I'm only getting one of those every couple of days. I'm not worried about it. Okay. Okay. What I'm worried about, I'm going to put my indexes where I'm really searching. So I'm searching on the vendor ID. That's the foreign key, and I can find that in 1/100th of a second. Okay. There's the idea. There's the rules. New rules. Don't index. Don'ts, and here's the do's. The don'ts and the do's are the important part. What don't you index? There's about 4 of them. Don't index what? Don't index what? Wanna? Primary key. Anybody else? Don't index?
Things that have small index values.
Oh.
That only have few variables, like that only have
Low cardinality.
low cardinality. That's what
Yeah.
I'm thinking of.
You don't have to say that, but
But
things that are
things that have high cardinality.
okay. Index things that are almost unique.
Mhm.
Okay.
Yeah, this is why there is no reason to index something that you want really do.
That's the third one. Don't index something that nobody cares about. If you're not using it, if nobody is searching on invoice number, because that's the one that the vendor gives it. No, that's the one that the vendor gives it the invoice number. I don't care.
And don't index those that change frequently.
Don't index things that change frequently. Those are the big ones. Yeah.
This is why sometimes when I used to work with mainframe, so my background is mainframe. We used to have somebody for database, and me myself, I used to be a programmer. Sometimes we used to ask, I want to have access for this field, but the database used to say, hey, you are gonna do it just only 5 times a week. No, we don't do index.
Yeah, you're only going to search 5 times a week. We're not going to build an index on it. We're just going to eat the cost. Okay. Now, to build the index, the command to build the index is just about as easy as you can get. Was right here. I think it was on this one. One more back. Nope, next page. Building an index is simple, 2-liner, nothing to it, but that is an incredibly, by the way, you have to have a special database privilege granted to you before you're allowed to create an index. The administrator has to give you the privilege grant. The system admin has to grant SW Smith create index privilege because you can do so much damage to the database with them. So the system admin creates the table, and most of the time it's like Juana was saying, you have to go to somebody else and ask for an index because they are so damaging if you do them wrong. Creating the index is nothing. It's just a little 2-liner, 1-liner. Create index. That can tie the database up for several hours right there, creating that index. Questions? Okay, I believe it's a fairly simple assignment. I ask you, what would you create indexes? Why would you make indexes? Hint, hint. Primary foreign keys are good bets. It's not always a foreign key. It's always an index, but you know, it's a good bet. There's a couple that aren't. I ask you some more. It's kind of a subjective assignment. What would you create a index on? Why would you create the index on this? Okay, and you're going to make up a story about why you'd create an index, because that's a really hot field. Because this, according to my business model, this field is going to be hot. So if it's, let's see, what would I know? I would not index. I would not index the. I might index the telephone number. There's nothing there that I can say I would not index. Probably wouldn't index the vendor contact first name. But I might, a phone number would probably make a good index. A date can make a good index. Can. Didn't say it would. Okay. Last name, yeah, those things would be good. And I think it's a pretty easy assignment. And with that, we have covered the topics that we're going to, the main topics of ITSE 2309, okay? So now for something completely different as I wrap up the day, I wanted to talk a little bit about the final, which is scheduled for May, what? May 17th, I want to say. Say again. May 10th is the last day of classes. And May 17th is the final. Okay, here's what I'm, now this is why, for those of you who are listening who are in the WW class officially, I know that I did not get that unlocked when I said I would get it unlocked. And I know that that's my bad, as they say, but I need those tests to be turned in as soon as you can, because tests aren't quite the same thing as grading exercises. I grade an exercise, just I look at the output and then I glance at it. When I grade a test, I have to grade problem 1 for everybody, then problem 2 for everybody. So I have to go through them one at a time for the whole class. So I don't come up with, I can't grade your test alone. I found that I don't get good consistency if I do it that way. Now, so I need them because I need to grade them, because I'm going to tell you why you want this to happen too. If you are happy with your grade, and I'll be happy to have a conversation with anybody via email. If you're off campus, you can have this conversation. You probably should talk to me about what your grade is. It is always good practice. You can always ask me, what is my grade right now? You know, if I didn't take the final, what would I make in the class? That's a valid question to ask me privately. Okay. And I will set a time to be online and and take those questions. Right, the final will be essentially a makeup. If you are happy, happy, smiling, then you do not need to take the final. One wants to take a test for what? How happy and comfortable you are. Yes, you may take the test.
So we take the test and our grades lower.
I'm not going there. Not going. You're not going to paint me into that corner.
Okay.
Brock, you don't want to take the test if you're happy with your grade, do you really? Okay. Well, then stop bugging me.
Just take it for yourself and just don't submit anything.
Yeah, just take it, grade it yourself. If you make me grade it, and you blow it off, I'm going to dock your grade. Yes. Okay. Enough of that. So that's going to be the deal. Now, don't tell the dean I'm doing that. Okay. Want to take it, then don't. If you're making an A in the class, then don't fool with it. You can still download the test. What else? Anything from anybody online? Who else still here? Paloma, you still here?
Yep.
Do you understand what I said about that?
Yeah.
Okay. Daniel, Ivan?
Yes, sir.
Yes, sir.
Okay. What I'm going to do the next couple of class meetings, I'm going to kind of bridge over into it. I want to cover a little bit of backup maybe, and some advanced topics that start into the programming class. They will step outside of SQL, of pure SQL, into something. We might do a little bit of Oracle if I don't know that I probably wouldn't have time to do, or it would take me 2 class sessions just to get Oracle loaded and running. I might demonstrate it, but I think what I'll do is I'll just continue on and step into the next chapter in the textbook. For those of you who are interested in signing up for the advanced programming class, we're just gonna keep on going in this book. And essentially what I typically do is I write an application where we put in layered security. We build in security into our database. And so we assume that somebody's trying to hack into us. And so we build layers, like an onion, layers of security into the database, and we write a web page interface. So it it was an online class. But I will do I will record the classes. And so, if you miss a class or something and you're gonna be out, then you'll still have access to the recording. So I'm gonna treat the class kind of like I do this one. But the more advanced topics do not lend themselves quite as well to a purely web format. Okay. Well, hey, did you guys get let's see. Did you guys get this file, Module 11 Design? Where I talked about the trigger?
Yes.
Okay, you got the file? Okay. A trigger would be one of those things. I typically don't do that next. I typically do that one about 3 to 4 weeks into the next class. I do triggers. A trigger is like a method. So if you were writing Java or C++ and in a class, and you would write a method that would sometimes they call those things triggers. Sometimes a method is called a trigger. Sometimes triggers are called methods here. So they're kind of the same thing. When you do something to the database that changes the data, you can write code that executes on the database. You can write this code that executes as the owner of the database, or it can execute as the sysadmin. And it can do anything that the owner can do or anything that the sysadmin can do. For example, if the trigger is owned by the sysadmin and you detect an attack, you can shut down the database, disconnect it, log everybody off. Pretty drastic. You can say, if you try to delete from the vendor's table, I'm going to take over with a trigger. And instead of deleting, I'm just going to go in there and set that field to 0. You'll think you're deleting, What'll really happen is that field will just get set to 0. Well, Python does that kind of stuff. Python is a good database programming tool, but actually this is built in. So the trigger is compiled. I'm going to talk a little bit about that over the next 2 class. We got 2 class periods left, and I'm out of SQL essentially. So instead of just busy work, I'm going to go ahead and do something that's a little interesting, I think, and I'm going to start. I'm not going to put it on the final. Okay, so we're done as far as that goes. So the next 2 classes, I'm going to be talking about some enrichment stuff, and so don't go complaining that I'm making you do something that's outside the scope of this class. I'm not making you do it. It's just I think it's worth doing, and I like having 1 or 2 classes at the end to kind of look and see what do you do with SQL now that we're such experts in it. Okay, I'm gonna wrap up there. It's noon. Okay, fire drill. Anybody online?
Me.
All right,
Okay.
thank you, Professor.
Bye.
Okay. Uh-huh.
Say
What's
bye,
your-
Mackenzie.
Bye-bye.
This one.
Uh-huh.
Bye.
Bye.
Bye.